Hello everyone. I have been teaching maths for more than 10 years. What I have found in these years that students in every grade are making these silly mistakes every year. So here I have come up with top 10 common mistakes. Don't miss the first mistake, which is so common and silly that can cost even a top grader mark. Watch this video very carefully and don't forget to share it with others. So let's start. Oh, this is the easiest one. I remember the trick my maths teacher told me that if I've got an even power on a negative base, the final answer will always be positive. So here, as we have negative 3 to the power 2, which means minus 3 into minus 3 equals to 9, which is totally wrong. What you have to notice here is that this negative sign is not the part of the base because it's not in bracket. So the correct answer will be minus 3 whole to the power 2 will be, take minus sign outside the bracket and you have 3 square. 3 square we all know that is 9. So the final answer is minus 9. However, if the question was written like this, negative 3 in brackets and square, which means negative 3 into negative 3, and that will give us the answer as positive 9. So make sure that you know that minus 3 square is not equals to negative 3 in bracket whole square. Now the next mistake is improper cancellation of the terms in a fraction. Here I have taken two examples. First one is 2x plus 4 by 2. Here we can easily see that in the numerator we have 2 and 4 which can be cancelled by 2. So what students do, they just cancelled out 2 and 2 and that's how the answer would be x plus 4. But actually this is wrong. The second example, one can easily just cut a plus b because these two are similar. And 4 will get cancelled out by 2. So the final answer could be 1 upon 2 plus 5a. But actually this is so wrong. Correct solution would be, first of all, we have to take 2 common from the numerator. So if you take out 2 as common, we'll get 2 into, inside the bracket we'll have x plus upon 2. Now because numerator 2 is in the multiplication with the with other term, that's why that 2 will get cancelled out by the denominator 2. So the final answer would be just x plus 2. In the second example, we have two terms in the denominator. First term is 4 into a plus b, second term is 5a. We have two terms. Wherever we have more than one term in the denominator, we can't just cancel it out. Although, if we have only single term in the denominator, let's suppose that 5a is not there. We have 2 into a plus b upon 4 into a plus b. Now, because in the numerator and denominator, we have just one term and a plus b is common to both numerator and denominator, it can get cancelled out. So a plus b from both sides will get cancelled out. We'll have 1 by 2 as the answer. We have to just simplify this equation. 9 minus 5 into x minus 8. In these type of questions, I have found two types of common mistakes that students do. Student number 1 does 9 minus 5 into x minus 8. So using distributive property, a into b plus c is equals to a into b plus a into c. According to this 5 will get multiplied to x and minus 8 both. So 9 minus 5x minus 40. This will give us the answer as minus 5x minus 31, which is totally wrong. The next type of silly mistake one can do is, because we have studied Bodmas rule, 9 minus 5 is 4, 4 into x minus 8 would be 4x minus 30. This is also wrong. If these are the wrong solutions, then what could be the correct solution? Yes, in these type of questions, we have to use distributive property, but we have to be very careful with the numbers. Here we have minus 5. This minus 5 is very important. That negative sign is very important actually. This negative 5 will get distributed to all the terms written inside the bracket. So if we're going to solve it, it will be 9 minus 5x minus 5 into minus 8 is positive 40. That will give us the answer as minus 5x plus 49. This is the correct. Do remember that. Whenever we have any negative integer before the bracket, if you want to open the bracket, it will get distributed to all the terms inside the bracket, but with a negative sign. These type of questions look very simple, but these are the most tricky ones. Here we have 3 into 2 to the power x equals to 36. What mistake students do is, they just multiply 3 and 2, which will give us 6x equals to 36. Now 36 can be written as 6 square, so we can write it as 6x equals to 6 square. Now as the bases are same, that means exponents must also be same. So x will be 2. But actually this is wrong. The correct solution would be 3 into 2x equals to 36. Here you first have to take that 3 to the other side. It will get divided by 36, which will give us 2x equals to 12. A log base 2 of 12. Obviously you will get an approximate value. Now the sixth mistake is operation with fractions. Whenever we have these type of questions where we have to do certain operations with the fractions, we have to be very careful. According to this, first we have to multiply 3. Let's do this. So 3 into 1 would be 3. And 3 into 5 is 3 by 15 plus 1 by 2. Now numerators get added to the numerator and denominator get added to denominator. So it will be 3 plus 1, 4 upon 15 plus 2, that's 17. 4 by 17, which is totally wrong. The correct solution would be, you just need to rewrite the whole number as fraction to avoid the confusion. Write 3 as 3 by 1. Now you can see that 3 by 1 into 1 by 5, that means 3 into 1 is 3, 1 into 5 is 5, 3 by 5 plus 1 by 2. Now I'm sharing the shortcut to add these two fractions. You just have to multiply the denominators, and for the numerator part just cross multiply. So 3 into 2 will be 6 plus 5 into 1 5, 6 plus 5 is 11 by 10. That is the correct answer. Fifth mistake is using inverse operations. As the word inverse suggests us to do the opposite operation. So here we have 3 by x equals to 6. So take that 3 to the other side, it will get divided by 6. So x equals to 6 by 3, which is 2. But this is wrong answer. Second example is minus 2x equals to 8. Take that 2 to the other side. If I take 2 to the right hand side, this negative 2 will become positive and it will be 8 by 2, that is 4. But actually this is also wrong. Before telling you the correct answer in this, obviously you can cross check your answer in these type of question. Put the value of x as 2 in your equation 3 by x, it will be 3 by 2. We can clearly see that LHS is not equals to RHS. Similarly, in the second one, minus 2 into x, which is minus 2 into 4 is minus 8, which is not equals to positive 8. That is why both the answers are incorrect. Now let's see correct solution. As I told you earlier, do write the whole number as a fraction. So 3 by x equals to 6 by 1. Now just cross multiply them. 3 equals to 6x, which will give you the value of x as 1 by 2. You can cross check, put that 1 by 2 in the equation, you will get 6. Similarly, for the second example, minus 2x equals to 8. Yes, we have to take that minus 2 to the other side, but this minus 2 is in the multiplication with the x. If anything is in the multiplication and you take that to the right hand side, there will be no effect on the signs. Positive number will remain as positive, negative integer will remain as negative. So that whole minus 2 will go to the other side and gets divided by 8. And that will give you the answer as minus. Mistake number 4 is treating a function like a number. I find it very easy when these simple distributive questions show up. Here we have sine into x plus y. One can simply think of the solution of sine into x plus y is using distributive property, which gives us sine x plus sine y. But that is wrong. Similarly, for the second question, log into x plus 5, log x plus log 5 is totally incorrect answer. It is a super common mistake one can do that sine and log can be treated like numbers and distribute them into their own argument. Sine and log are functions, not the numbers. Actually, this is an identity sine into x plus y. Its RHS will be sine x cos y plus cos x sine y. Then there's log part. There's nothing we could do to simplify this log part. You can't expand log into its own argument, so don't do that. Next, mistake number 3 is about the exponent laws. These questions look very simple. Here we have x to the power 5 into x cube. Because we have multiplication in between, that means power will get multiplied. So x into 5 into 3, that's 15, x to the power 15, which is wrong. Now look at the second example, x to the power 8 upon x to the power 6. Because we have division in between, that means exponents will get divided by each other. So x equals to 8 by 6, which will give us the answer as 4 by 3, x to the power 4 by 3. That is wrong. The last one, 5 cube into 5 square. So power, because we have multiplication in between, 5 into 5 will give us 25. And if we multiply the powers, we'll get 6. 25 to the power 6. That is incorrect. Then what will be the correct solution? According to the exponent laws, whenever we have same base, powers get added to each other. So the correct solution of the first one would be x to the power 5 plus 3, that is x to the power 8. For the second example, whenever we have same base in the division, exponents get subtracted. The final exponent will be numerator minus denominator. X equals to 8 minus 6, which gives us x square. The last one, 5 cube into 5 square. Here again we have same base as 5. That is why powers will get added to each other. So it will give us the answer as 5 to the power 5. Now comes the mistake number 2. Here we have to calculate the square root. Square root of 9 is 3. Okay. If you want to cross check, obviously you can check. Just put the value of x as 3. 3 square is 9. That is correct. But do you think that this is the complete answer? Actually, no. This is incomplete. But have you ever thought of negative 3 square? Minus 3 into minus 3, which gives us positive 9. So don't you think that minus 3 is also the square root of positive 9? There are some equations whose solutions can be more than 1. Therefore, whenever you have to calculate the square root of any number, you have to consider both positive and negative values. This is the most common mistake students do. Here we have x plus 3 whole square. We have to calculate the square. They just distribute square to all the terms inside the bracket. So the answer would be x square plus 9. But actually this is wrong. If you take another example of a plus b whole square, the answer could be a square plus b square. No, this is the biggest mistake one can do. Actually, there's an identity of a plus b whole square. Actually, anything to the square, what does that mean? The same number is multiplied by itself 2 times. A plus b whole square equals to a plus b into a plus b. And using the distributive property, A will get multiplied to all the terms of the second bracket, and similarly B will get multiplied to all the terms of the other bracket. If you simplify this, you will get a square plus 2ab plus b square. This is the correct solution of a plus b whole square. Similarly, if you consider the example of x plus 3 whole square, after simplification you will get x square plus 6x plus 9. This is the correct answer. Okay then, now that I have gone over these common and silly mistakes, I hope you never do these mistakes again. I have also made a video long back about silly and repetitive mistakes that most of the students do. Do check that video out as well. Link is in the description box. See you in the next video. Happy learning.